For as long as I can remember, the story of our universe has always started with a bang, a single explosive moment that created, well, everything. But what if that's not the whole story? What if it's not even the right story? Today, we're going to look at a pretty radical new idea, one that could completely flip our understanding of where it all came from. So, let's get right into it.
I mean, really think about this for a second. What if the Big Bang just never happened? What if, instead of starting from one single point, our universe is just in this constant state of balance, always recycling, always regenerating itself? That's the huge question at the heart of what's called the S-matter hypothesis. It's a whole new framework that paints a picture of a cosmos that didn't have a beginning, and maybe, just maybe, won't have an end.
Okay, so before we can really appreciate why a new model is even on the table, we've got to look at the cracks in the one we've got now. Our standard story of the universe. It's been incredibly successful, don't get me wrong, but it's also got some pretty major unexplained plot holes.
Right, so the current reigning champ in cosmology is something called the Lambda CDM model. And look, it's brilliant. It does an amazing job explaining things like the cosmic microwave background, that faint afterglow from the universe's early days, and it totally nails how galaxies got together to form this huge cosmic web we see out there. It's the story we've all been taught.
But, and this is a huge but, there's a catch. The whole model rests on a few key ingredients that, honestly, we've never actually found. It needs this invisible stuff called dark matter to act like cosmic glue holding galaxies together. It needs a mysterious, dark energy to explain why the universe is expanding faster and faster. It needs a period of cosmic inflation right at the start that's like faster than the speed of light. And the whole thing kicks off with a singularity, a point so dense and hot that all our laws of physics just stop working. They completely break down.
So what do you do with all these puzzles? Well, the S-matter hypothesis has a wild suggestion. It says the answers aren't in our universe at all. They're just beyond it, in a completely different dimension of reality.
All right, so the first piece of this puzzle is something called S-matter. The easiest way to think about it is like a giant cosmic reservoir of raw potential, or maybe like an unpainted canvas before the artist starts working. It's this fundamental substrate of pure, unstructured energy. And when scientists say it's non-baryonic, that's just a fancy way of saying it's not made of the normal stuff, the protons and neutrons that make up you, me, the planet, the stars. This stuff exists outside of our normal 4D space-time, and it's the raw material from which everything else is formed.
So where does all this S-matter hang out? Well, this is where it gets even cooler, in the fifth dimension. Now, hold on, this isn't like in the movies. You can't just hop in a spaceship and travel there. It's way better to think of it as a different kind of reality. It's a timeless, spaceless realm that's basically the engine room for the universe. It's the bridge that allows regular matter to turn into S-matter, and for S-matter to turn back into regular matter.
So you put these two things together, the S-matter and the fifth dimension, and what do you get? You get a gigantic cosmic recycling system. It's like a perpetual motion machine for the entire universe, keeping everything in this constant dynamic balance, maybe forever.
And this engine, it's pretty simple, really. It runs on a continuous four-step loop. First, you've got matter in the super dense parts of our universe collapsing in on itself. Then, that matter goes through a kind of gateway, breaking down into pure S-matter back in the fifth dimension. Next, that S-matter flows back into our four-dimensional spacetime. And finally, it pops back into existence as fresh new hydrogen in the emptiest parts of space, ready to kick off the whole cycle again.
Okay, let's break that down a little. Step 1 and 2. Where does matter actually leave our universe? The answer? Black holes. In this model, black holes aren't the cosmic vacuum cleaners we usually think of. They're not dead ends. They're actually active dimensional gateways. The idea is that inside a black hole, matter gets so crushed and scrambled that its 4D structure just dissolves, and it transitions back into that timeless, formless state of S-matter. So if black holes are the exit, where's the entrance? Well, it's in the emptiest places you can possibly imagine. Those massive cosmic voids, the huge empty bubbles between the filaments of galaxies. This hypothesis says those voids aren't really empty at all. They're genesis fields, cosmic nurseries where S-matter flows back into our universe and becomes brand new hydrogen, which is, the fuel for all future stars and galaxies.
Okay, so we've got this really elegant recycling system. It sounds cool, right? But does it actually fix the big problems we talked about at the beginning? Well, this is where things get really interesting.
So let's connect the dots here.
How on earth does this cosmic recycling loop get rid of the need for dark matter, dark energy, and even the Big Bang itself?
Well, the explanations couldn't be more different. Take dark matter. Instead of some mysterious, undiscovered particle, it's just the gravitational pull we feel from all that S matter existing in the fifth dimension. And dark energy? Forget some strange force pushing everything apart. In this model, it's just the outward pressure created by S matter pouring back into our universe in those cosmic voids. The Big Bang? Gone. Replaced by a universe that just emerged from a timeless balance. And what about the black hole information paradox? Solved. Information isn't destroyed. It's just converted into a different format in that 5D realm.
And really, this is the killer feature. The S-matter model just completely sidesteps the single biggest problem with the standard model, that pesky singularity. You don't need a moment where all the laws of physics go out the window. The universe didn't have to start from some impossible, infinitely tense point. It just is. It exists in this beautiful, continuous loop of transformation.
And that leads to a really profound, almost philosophical shift in how we think about, well, everything. In this model, time itself isn't fundamental. It's something that emerged. Think about that. The idea is that time as we know it, past, present, future, only kicked into gear when some random fluctuation upset a perfect, timeless balance, starting the first domino falling in the chain of cause and effect. Now, I know what you're thinking. This is a fascinating story, a beautiful idea. But for it to be more than just a cool sci-fi concept, it has to be actual science. And that means it has to be testable. It has to make predictions that we can go out and actually look for. And that's the bottom line, isn't it? Is this science? Because a really good scientific idea isn't just about being elegant. It has to be falsifiable. It has to stick its neck out on the chopping block and say, okay, if I'm right about all this, then you should be able to go out and see this specific thing.
And you know what? The S-matter hypothesis does exactly that. It makes some very specific, very concrete predictions. It says we should be able to find clouds of brand new, pristine hydrogen sitting in the middle of those giant cosmic voids, places where they have no business being. It says we should see a particular kind of gravitational lensing, light being bent around the edges of these voids, caused by the gravity of the S-matter. It even predicts weird patterns in redshift and strange flows of neutrinos that line up with these voids. The best part? These aren't just ideas. These are real, tangible signals that our telescopes, both now and in the near future, can actually go out and search for.
And that really brings us to the final, and I think most provocative, idea here. What if, for all these centuries, we've been asking the wrong question? Maybe the biggest mystery of the cosmos isn't how did it all begin? Maybe the real question is, how does it all stay in such perfect, unending balance? It's a shift from thinking about a universe born in a violent explosion to one that's sustained by a quiet, elegant, and timeless cycle.